All right, good afternoon or evening. This is Unit 2, Video 3. We're going to work on solving and graphing linear inequalities. Okay, so this is going to be graphing inequalities in only one variable. So as you can see by looking at this as you start to copy it down, is we are going to be given an inequality. We are going to look to graph it. Since it is a one variable inequality, we will be graphing this on a number line. And then we're going to write our solution in an interval. We have it written in an inequality, but I'm going to write it also in an interval. So for the first one, x is greater than 3. On your number line, it's nice to include 0 so that you're representing what side of 0 this is on, either the positives or the negatives. So we're going to place 0 there. You do not have to have a tick mark for every single value between 0 and the number you're looking for. But it is nice to at least put a space there. And because this is a greater than, I'm going to just use an open circle. If it was a greater than or equal to, we would have a solid circle. So this would have led us to having a solid circle on our number line. And then I'm going to shade every value that is greater than 3. Okay, we're also going to use the word exclusive because we are not including 3 itself. That would be this one down here. This would be inclusive. So this is exclusive. Okay, so to write this as an interval, we're going to say we have a soft bracket on 3, and this goes on to infinity, and we know that infinity always has a soft bracket. If I wanted to write this as set builder, it's actually already set up for you. In set builder notation, I would have the set of x such that x is greater than 3. So this already uses our inequality format for it if we were to choose set builder. But interval notation is actually much more commonly used in our mathematics, so you'll see that more often. All right, let's try the next one where we have x is less than or equal to less than or equal to 9. If this were open, or if this was just a less than symbol, we would have had open similar to our greater than symbol on our first example. So we are including, this is inclusive to the number 9. So again, I am going to put 0. And if you'd like to space it out, you can count by 3s, or you can go ahead and just place the 9 far enough away from the 0. We're going to put a solid circle on the 9. And because this is less than, we're going to shade in the left direction, representing all numbers less than 9 inclusively. Oops. So to write this in an interval notation, I'm going to use negative infinity first. I'm always starting with my smallest number in my interval. 9 is not smaller than negative infinity, so negative infinity comes first. But when I write my 9, I'm going to use a solid bracket because this shows that this number is inclusive. And that is our interval notation. Again, if I chose to write this in set builder notation, just so you're familiar with the different notations, I'll have the set of x such that x is less than or equal to 9. So it does play into exactly the same as the inequality, which makes set builder kind of a nice easy transition from the given inequality. All right, let's go ahead and actually try to solve some of these. So on this screen here, I'm going to go ahead and solve this using the same setup that we would have in an equation with one extra thing. So let's get started. I'm going to subtract 5 from both sides. And in this step, because I am dividing by a negative number, I'm going to have to switch my symbol. So I'm switching my symbol over to a less than, and it's less than positive 4. So on my number line, if I were to graph this, you might include 2 and you might not. It does not matter. You can even put all the tick marks, 1, 2, 3, 4. But I will put an open circle and I will shade less than. And in my interval notation, I would write negative infinity to positive 4 exclusive using another soft bracket. Let's try this one. In this one, I may choose to add the 3x to the other side, or we could subtract the 2x to the left side. Either way, you'll end up with the same answer. I'm going to actually go ahead and add this to the other side just to show one more thing for you. And I have 4 is less than or equal to 7 plus 5x. I'm going to subtract 7, and I'll get negative 3 is less than or equal to 5x, and divide by 5. So this gives me negative 3/5 is less than or equal to x. It's best to write this so the way we would read it normally is x is greater than or equal to negative 3/5. So if you're thinking, well, what if I had subtracted the negative 2 to the other side, or subtracted the 2x to the left side? You would have had a negative 5x, and therefore in your last step you would have had to divide by a negative number, and therefore switching the symbol from the less than and that it began into the greater than that the answer will be. So regardless of the steps you took and the order in which you took them, you'll still end up with a greater than symbol in the end. On my number line for this one, I'm going to put my 0 here, and this I'm actually going to show where 1 is, and that way I can show, or negative 1, so I can show where my negative 3/5 would fall. I am going to go ahead and use a solid circle on there because this is inclusive, and I'm going to then shade everything that is greater than or equal to negative 3/5. In my interval, I'm going to use, or interval notation, I'm going to use a solid bracket or a hard bracket on negative 3/5, going to positive infinity with a soft bracket. Please try these 4 problems on page 156, and if you need to reference back to the video to take any notes on anything in either writing it in interval notation or graphing, please do so. See you guys in class.